The title for the first section of notes today is More Simplifying Exponents. The first problem, inside parentheses 2 to the second power divided by 5, close parentheses to the third power. First step we can solve is we have an exponent on the outside of 3. This 3, like the previous sections, goes to each number and each term inside the parentheses and also in the numerator and denominator. When you have an exponent raised to another exponent outside the parentheses, this is where you multiply. 2 would stay the same as the base, and the exponent you'd multiply, and it'd be 2 to the 6th power. Bottom of the fraction, you'd have 5 to the first power. You can multiply again, and you get 5 to the third power. Simplifying, we just need to multiply the numbers out. 2 to the 6th power is 2 times itself 6 times. And 5 to the third power is 5 times itself 3 times. 2 times 2 would be 4. 2 times 2 again would be 4. And 2 times 2 again would be 4. 4 times 4 is 16. 16 times 4. The numerator or top of the fraction would be 64. 5 times 5 is 25 for the denominator. 25 times another 5 is 125. Check to see if you can reduce fractions. This one cannot be reduced, so your final answer is 64 over 125. Second question. Inside parentheses is the fraction 2/3 or 2 over 3 to the negative 1 power. This negative 1 exponent again goes to each number and each term inside the parentheses. So it'll be 2 to the negative 1 power and also 3 to the negative 1 power. Negative exponents from previous sections make the fraction flip around. If it's 2 to the negative 1 in the numerator or top of the fraction, that would go to the bottom or denominator of the fraction, and the exponent changes to positive 1. Likewise, in the denominator, if you have 3 to the negative 1, the negative 1 will go to the numerator or top of the fraction and become a positive 1. 3 to the first power is just 1. 3 to the first power is 3. 2 to the first power would be 2. And your final answer would be 3 over 2. Third question. C to the 5th power divided by C to the 9th power and raised to the 3rd power. Again, the exponent outside the parentheses goes to each number and each exponent inside the parentheses. If you have 2 powers separated by parentheses, you'll be multiplying. 5 times 3 would be C to the 15th. Also for the denominator, 9 times 3, still have a base of C, and 9 times 3 would be 27. Simplifying still. Subtracting exponents when you divide. Again, that's from a previous section. 15 minus 27 would be negative 12. You subtract the numerator from the denominator. Negative exponents, again, mean you'll have a fraction. If you have a negative exponent, you can put that on the bottom of the fraction. It becomes positive. There's an imaginary 1 in front of the C. So your final answer is 1 over C to the 12th. Last question for this section. Inside parentheses is 4n divided by 2 n squared, close parentheses, to the third power. The 3 again is going to go to the n on the inside. It also goes to the coefficients of 4. Goes to the 2 exponent on the bottom, and it also goes to the coefficient of 2. So this 3 gets distributed to each number, each variable, to get the correct answer. 4 to the third power would just be 4 to the third power. There's no exponent on the n, but the 3 also goes to the n to the third. 2 to the third power in the denominator. N has an exponent of 2. Exponents outside the parentheses, again you multiply. 2 times 3 would be 6, and you have n to the 6. Simplifying, 4 to the third power, again this 4 times itself 3 times. 4 times 4 would be 16. 16 times 4 would be 64. N to the third would stay the same. Divided by 2 to the third power. 2 times 2 is 4. Times 1 more 2 would be 8. N to the 6 would stay the same. Simplifying again, the x coefficients out front, you can divide those. 64 divided by 8 would be 8. Exponents, when you divide, you'll be subtracting these. 3 minus 6, which would be negative 3. And your final answer, since you have a negative exponent, make it a fraction. The 8 would stay on top. It does not have a negative exponent. The n, though, with a negative exponent goes to the denominator, and you have 8 over n to the third. Here are 5 example questions. The last section of notes today is titled More, Simplifying Exponents. Next problem is 3 to the second power times 5 to the 0 power over 2 to the third power. In this question, there's no parentheses, so we don't have to worry about distributing exponents. We just need to simplify each term with an exponent. 3 to the second power is 3 times itself 2 times, which would be 9. 5 to the 0 power is the same thing as any number to the 0 power, which is 1. And the denominator, 2 to the third power, 2 times itself 3 times, is 2 times 2 times 2, which would be 8. The numerator, 9 times 1 is 9, 8 on the denominator, so your final answer is 9 over 8. Second question. Inside parentheses is 2m to the fifth power divided by m to the second power. The exponent outside is negative 4. Again, this negative 4 goes to each coefficient and each exponent on the inside of the parentheses. 2 to the negative 4 power. M stays the same, but the exponents inside parentheses you multiply 5 times the negative 4, which is negative 20, divided by exponent of 2 multiplied by negative 4 would be m to the negative 8th. Any negative exponents, again, are going to switch the fraction. 2 to the negative 4, the 2 goes to the bottom of the fraction, from top to bottom, becomes a positive 4. The m is also in the numerator or top of the fraction with a negative exponent. That'll go to the denominator or bottom, and the 20 becomes positive. Also m to the negative 8. It's at the denominator or bottom of the fraction. It'll switch to the top and become a positive 8. Simplifying, the m's you can combine. These will be subtracting. Anytime you divide exponents, if they have the same variable, exponents you can subtract. 8 minus 20 would be negative 12. 2 to the 4th power is 2 times itself 4 times. 2 times 2 is 4, times 2 more is 8, times 2 more is 16. Last part of the question, we have a negative exponent. Negative exponents in the numerator go to the bottom of the fraction and become positive. The 16 stays in the denominator. It does not have a negative exponent. The numerator or top of the fraction, there's an imaginary 1 in front of the m. So your final answer would be 1 over 16 m to the 12th. Last question for this section. Is in parentheses n to the 4th times n divided by n to the negative 2nd outside parentheses to the negative 4. Again, one of the first things you can do is to distribute this negative 4 to each variable on the inside. N to the 4th to a power of negative 4, these you would multiply, and that would if this one does not have an exponent, it just stays the same as n to the negative 4. And if you have a negative 2 in the denominator as an exponent, multiplying, negative 2 times negative 4 would be positive 8. Simplifying again. If you have negative exponents, you can rewrite those in the denominator. N to the negative 16 would be n to the positive 16. N to the negative 4 would be n to the positive 4. N to the 8 is positive, so it would already stay in the denominator. And again, if nothing is left on top, no other coefficients, you can leave a 1 in the numerator. Final answer, just combine all the n's. 1 is on top. If you're multiplying variables together, all the same variables, you can add the exponents. 16 plus 4 would be 20. 20 plus 8 would be 28. Final answer is 1 over n to the 28th.